Hello everyone. We will wait for a couple of minutes so that everyone can join, and then after we will start today's lab session. So we'll wait for another 2 minutes. Hi, hi Shubham.
Hi, sir.
Yeah, how are you?
Sir, I'm good. What about you?
Good, good. So you were there and not there in some of the classes past week.
Yes, sir. I was not on last week and
Okay.
was busy. Yes, actually, there was a family function on last Saturday,
Okay.
so that's why I have to miss that class.
Okay, that's great. So is there any issues coming in solving the assignments?
No, sir. No.
Okay, so like if you miss any time, you can go through YouTube recordings. So
Yes, sir. Yes,
and
sir. I
questions will
covered
be
that.
there.
I covered that video.
Yeah, sure. And if you want to cover it fast, you can also go through the questions which we've uploaded on the drives. So yeah, you can also go through that as well.
Yes, sir.
Yeah. So we'll wait for another 1 minute and then after we'll start.
Sure, sir.
So are you able to see my screen?
Yes, sir. It is visible.
Okay, fine. That's it. So let's go. So hello everyone. Welcome to this week 9 solving session of Advanced Geomatics Engineering. And today we are going to cover a bit on drones. So in previous class we went for lidar and we just checked like how lidar works, and then we saw some of the applications also, that if we have lidar data which is in point cloud format, then how to visualize the data into various way in QGIS, how we can extract the elevation profile from that. So those kind of informations we got from the last week. In today's week, we are going to talk more about drones, which is a new era of surveying, if we can say. And its works similar to what we had in LiDAR. It has sensor or different things are fixed, but the thing is like it's a remote controlled or pilotless unmanned aerial vehicle. So you can have it for various applications, not just for imaging. You can have it for various applications, whether it's from any sector. So that is a advantage of drones compared to other surveying methods. So today we'll start solving the question answers, and meanwhile we see the basic concepts also. So we'll start with this one. As I said, like drones has multiple applications in you can take any field. So which of the following is or are not the surveying applications which we cannot do using drones?
Sir, contour generation, irrigation planning, and geointelligence for homeland security.
So those three we can do or we cannot do.
Sir, we can do underground utility mapping is not the application of UAV.
Yes. So we cannot do the underground because if something is there
Yes,
below the ground, we cannot do that. For that, we are having different devices like such as we have GPR, which is ground penetrating radar, and MSAWR that also we are using for that purpose. Now the second question is which technology provides better resolution of photographs?
sir, UAV.
Okay, so compared to everyone, like we are having the height or altitude at which we are flying the UAV is very less, and because of that, we can cover focus on very small area, and we can get very like good amount of details. So because of that, spatial resolution can be increased. But this another disadvantage here is we can cover very less area because it's flying at low altitude. So if we want to cover the bigger area, we need more number of flights or more number of revisits from the same area. So depending on what kind of applications you are interested, you can select one. So in case of higher spatial resolution, UAV is good. Hi Avinia. Welcome to the class. So our third question is, what is the full form of UAV?
Unmanned air vehicle, sir.
Unmanned aerial vehicle.
Aerial vehicle.
Option number A. Then, what is the primary purpose of using ground control points in a drone surveying mission? To serve as measured reference point to accurately georeference the collected
Sir,
aerial
for
images?
georeferencing.
Yes. So suppose if I take any imagery and if I want to do georeferencing, how many number of ground control points are required?
Sir,
Minimum of
minimum three.
minimum three. Yes,
Yes, sir.
that's true. But if we have some image, so better to take four around the corners because, or if we are taking
Yes,
three, then how should that locate it? Suppose if we have an rectangular map or rectangular image, so how that 3 points should be spread out?
sir. Possibly on the corners of the image so
So
that they
if
can
we,
cover the whole
yes,
image.
so if we take corners, then we have four corners, and if we are just taking three, then at one corner it will give distorted
It
kind
will
of image.
automatically
Yes, it will do
estimate the.
it will do, but when you will do that thing, the map will distort.
Yes, sir.
Okay, so if you are giving near corners, you should give four, but yeah, at least yeah, you need to give three, but that three should be equally spaced in your image so that there should be no uh, hello, welcome to the class. So there should be no distortion. So like once we are doing the drone survey, So how we will fix the GCPs? Like, let's say we want to, I am collecting a data using drone. So how will I fix, like which point I will take as a GCP? So in my survey area, how
Sorry,
will I
can you
decide?
repeat that?
Yeah. So if I'm doing a drone survey, okay. So how will I decide that which point is my GCP? You told
So
right
the
that we need
centroid of the image,
centroid of,
centroid of the image, if I can make,
but we
if
do
I can
not know,
assign only one GCP, then
but we do not
centroid is
know,
the,
but centroid if we'll take, we do not know the coordinates. That's why we are doing georeferencing.
yes,
Okay, so that's what I'm asking. Like, how do we get to know that this point is a GCP or ground control point? Suppose you
so there are
consider,
some
yes,
conventional marks which indicate us like this is a GCP.
yes. So which kind of marks? So basically, if you go on survey, when we do the drone survey, we will put this
Yes,
kind of markings on field.
yes.
So that once we are done with the survey, we have measured the location at this cross section using the GPS. Just let me turn on my pencil. So basically, we know the coordinate at this location using GPS, and after that, we will put this kind of sheets while doing the drone survey. So that once we collect the imagery like this, wherever that point is that, there will be that point we will take as a GCP. But let's say someone else has collected the drone without this one, this GCPs. So in that case, what you will do? Let's say you do not have this kind of things on your drone image. So how will you do in that case?
Sorry, are you asking for undulating terrain?
No, just terrain is same, okay, but instead of this, let's say I'm not putting this while doing the drone survey. I'm not putting
Yes,
this kind of setup. So how will I get my GCP? So basically, when we refer GCP, it's ground control point. So that we just want to do georeferencing or we want to align our drone imagery. That how it will align on the
so
actual map.
can we take help of any georeference, another georeferenced image
No,
if,
that we
by
can do,
image to
but
image
that
registration?
also we can do. But let's say if we do not have any georeference image also, then what we can do is we can take the structures which are permanent in nature, such as temple, church, mosque, or we can take up bridges, the starting location of the bridge, or any like town town plan, like some old building is there which is since like from long time, or some any permanent structure that we can refer and that will not change with time in the nearby future. So those points we can take as a GCP. So now what we'll do, I will take any of the corner of a building as a GCP, and then I will go with my GPS and collect the point of that particular corner or that particular part of temple or that particular part of bridge. So that now after 5 years also, if I want to use the same thing as a GCPs, then it will not hamper the geometric accuracy or the precision of your image. So like that, if we do not have this kind of measures during, or if you just in your terrain, you do not have any permanent structures such as buildings or something else, then you put this kind of sheets using which you find the GCP. But if you have the structures, then there is no need to put this also. Did you get my point?
Yes,
So basically, in the image, once we have some kind of, let's say, corner point of plot or something is there on a park which is permanent in nature. So we will keep those points as a georeferencing point or GCP points. And then after we will perform the georeferencing operation and we will overlay the image which we collected through drone on a particular base.
yes, got it, sir.
So now there is a next question is, in the context of geomatics and drone data collection, what is an orthomosaic? A 3D point cloud model of the surveyed data area, A flight plan used to automate the drone's movement.
Sir, option C,
Yes. So
geometrically
ortho,
corrected multiple images.
yes. So orthomosic, it's like a stitching a different image. So if we are collecting a drone data, obviously the IFOV, instantaneous field of view of drone, will be less compared to satellite and other aerial vehicles. So because of that, we cannot capture a larger area at a single time. So we'll take multiple images and then we will stitch those images with each other and we'll create a bigger map. So that process is known as a orthomosaic. And here what the word ortho means.
Sir, ortho means like same from everywhere, like scale is same at every point.
So ortho means taken at a nadir view, or you can say exactly looking downward. So those that we learned in the photogrammetry, that orthometry and something like we are just looking at. So it will look as a map.
Perpendicular.
Yes, exactly. So exactly at the bottom, not at any tilted angle. So during photogrammetry, we learned that in generally photogrammetry, we considered the inclination of till 3 degree. But here they are referring to orthomosic. Here also we can consider a little bit inclination, that is fine. But the image should be orthometric image, exactly taken at a 90-degree angle from the, like, exactly looking below. So that then that only we can mosaic. Okay, so how this will happen is something like this, that you are taking multiple images and then of a particular area, and then after you will compile every image using orthomosaicing, and then you will get a single image, continuous image for entire area. So now the next question is, which of the following is true for UAVs? Only pilotless operations, it can be autonomous or remotely controlled, at least one operator is needed to control it remotely, or none of the above.
Sir, B and C. It can be autonomous or remote control, and at least one operator is needed to control it.
So it can be autonomous or remotely controlled, that is true,
And
and
C,
at least
sir,
one
at
operator
least
is
one op
needed. So here, yeah, at least one operator is needed to control it remotely. But here think about that, if you are putting your drone on auto mode, like you have given the command, then you do not need anyone. Like just start the operation, like some person will start. Like for
Sir, but
control,
at initial,
yes, initial we have to give, but after that we do not need any assistance from pilot. Okay, so yeah, currently
sir,
the both
then
options are
is
correct.
it wrong or right?
No, no, it's right, right.
Okay.
I'm just telling that here that at least one operator is needed. That is only for initial purpose.
Yes, sir.
Yeah, so that's right. I mean, you are right. So now the next one is, which of the following is
Sir,
not a,
radio.
yes?
Sorry, sir, I disrupted you.
No, no, fine, fine. Go ahead.
Sir, I was saying like a radio controlled vehicle is not the name of any firm.
Yeah, anyone else? Guys, you can also speak. I mean, you can give the answer if you know, so that we can do the discuss and it will make you prepare for your exams also for this NPTEL. So here the answer is remotely flying object, not the radio controlled, because how we are connecting to drone is radio controlled signals. So if you see the PPTs, there are multiple names of UAVs are written, such as radio controlled vehicle, remotely piloted vehicle, remote controlled vehicle, autonomous controlled vehicle, pilotless vehicle, unmanned aerial system, aircraft system, and drone. So if any flying object is there, like saucer or something like flying object or machine without a pilot, so that can be referred as any of the following name. Okay, so basically one
Sorry,
thing is it's a radio based, that's why it's a radio controlled also. Secondly, it's like remotely we are controlling it, so remote word will be there. autonomous, like in auto mode also we can do that. So autonomous control can be also possible. Pilotless because we do not need it. So that is also true. And unmanned. So it's like no man is inside the UAV or flying object. So these are the different names. Which of the following can provide the accuracy of few meter?
UAV.
Yes. So as we go from UAV to satellite, what will happen to accuracy? So is it
Sir,
will it increase or
it
decrease?
Decrease.
sir it
Yes, it will decrease. True. So why? Because if we are going to satellite, we are going above and above at different altitudes. So because of that, our spatial resolution will decrease. And through drone, like we can go to centimeter level also. Few meter, like depend on which sensor we are operating it. But yeah, satellite also we can go to that level, but we need to adjust our satellite in that way, because in the remote sensing slides you also heard about the sport and pardias and some other satellites which are also having the same accuracy. But yeah, if you compare it with the configuration, UAV has the most accuracy compared to other thing. So if we want to compare it all together, so UAVs you can go from centimeter level accuracy to meter. Then the availability of UAVs are very high, like you can get it anytime, and the operation mode can be autonomous or remote controlled. Then payload is limited, like we cannot put whatever we want to put. So if you are interested in number of things, number of sensors, number of things what we want to do, we cannot put everything on drone. So that has some limitations with the payload. Then operating cost is very low compared to the other three. Then there is a helicopter. So in that we can get the accuracy of hundreds of meter. Degree of availability is high. Operation mode is a human pilot. Payload capacity is also limited, and operating cost is medium. Now in system airborne, we are having resolutions up to 50 meter we can have. Then availability is moderate. Operation mode is human pilots, and payload capacity is much more than the helicopter, and the operating cost is bit high compared to helicopter. And then we have satellite, so resolution is coarse. Availability is also not that good. If we are having geostationary satellite, then it is available for all the point of time, which can be useful for weather monitoring. But if we take any other satellites, let's say Landsat, Sentinel, then the temporal resolution is around 16 days, 8 days. After 5 days, you will get some time. So the availability is poor, and like we have to fix one satellite in the orbit, and then only according to its configuration we'll get the data, not as per the our requirement. Whereas in the other three, we can get it from our requirement. Like if something happens, we can do the like fly the drone and collect the data. And operation mode is also autonomous in case of satellite, and it also has some kind of limited payload capacity, and operating cost for satellite is too high. So these are the comparison of four different systems through which we can collect the data from sky. Now based on that, like identify which of the option is true here. So UAV with high availability and high operating cost. Airborne is having poor availability and high operating cost. Helicopter has high availability and medium operating cost. And satellite has moderate availability and too high operating cost.
Sir, option C.
Yes, true. So we'll just see why not others. So UAV, it's available at any point of time, and it has high operation cost. No, it has very less operation cost. Second one is the airborne. So airborne has like around kind of moderate availability, and then operating cost is not that high. Oh, sorry, operating cost is high for airborne, and then for helicopter it's medium, and satellite like availability is poor, and then it's too high. So this one is right, but this one is not right. Now the next one is which of the following is or are Advantage of drone. Cheap and cost effective for larger surveys, can be operated easily in populated areas, real-time continuous data generation, and effective for spraying pesticides and chemicals.
So A, C, D,
Yes,
and
B is incorrect.
yes, sir.
So we have to be very careful when we are doing a survey in populated areas where humans are there. If something will happen, then it will create a lot of trouble for the person because the speed at which these propellers of drones are moving, it's very costly. So in colleges also, when we have these drone competitions or something or other, it's been very like designated zones where you cannot go during that flying time. You have to be very careful. So that is the advantages. And then the next question is, which of the following is not a disadvantage of drone? Weather susceptible, privacy and security issues, need for a qualified operator, or costly operations for topographic survey.
So D.
Yes, so if we are doing topographic survey, the area which we are surveying is very high. So in that case, the drone will become like good point of survey equipment because it will cover larger area in lesser time, so overall cost will get reduced. So we will see like different advantages and disadvantages of drone. So you can see here that main advantages of drones are that it's cheap and cost effective compared to other airborne helicopter and satellites. Then we are having spatially very high resolution of data if we are working for very small area. The drones are very good. The high accuracy we have, easy to deploy. Then no hindrance from clouds. So if clouds are there, also we can do the survey by great tool for surveillance. Like if we want to do surveillance, it's very great. Sometimes border also, and if you see seen that in this current war-like situations, also people have used drone for various military purposes also. Then it's able to provide data for broader area also. If we adjust the instantaneous field of view in such a way, then it will provide the broader data also by increasing the IFOV. Then high flexibility and mobility, real-time continuous data we can also get from drone. Very useful in disaster-prone regions such as like lots of floods are happening in Punjab and Himachal and then the northern part of India. So landslides are happening in the part of Kerala and some part of Himachal. So to avoid glacial lake outburst are there. So for all those things, drones will become very important tool for those kind of regions. Then it is good for delivering goods, medicines, or using memes also that lots of people are using it for various purposes, normal grocery to some other advanced equipments for drone delivery. Then very effective for spray and pesticides with this application from agriculture side. Then communication of warning and emergencies or something is going to happen, flood is going to come in a village. We can reach quickly to the particular village and we can disseminate the informations quickly using drones. And the disadvantage is that capabilities are less because payload is limited. So if we cannot put so much thing on drone, coverage is also less. So if we want to cover a large area, it will take more time compared to other satellite airborne devices such as helicopter or airborne sensors or satellite sensors. Then care is required to use in populated areas. So basically, we should follow the privacy and security issues and other protocols given by the authorities, such as do not fly near the airports or do not fly near to the military bases or such kind of things. then permissions are required to fly and collect the data for some times. So there is one site, I mean, if someone is doing a something with drone, so there is a like one authority, DGCA, so this gives permissions or like you need to buy license or something. So you can go to their website and you can check out. So in this website also you can also look through that which zones are there where you can fly the drone without any permissions, which zones are there you need permissions, which are the red zones where you do not fly drone at any cost. I mean, if you have permission also, then you cannot do. So those kind of thing you can check it over here. Mm, So here you will find different maps. So it will be like, see here, accidents and reports are also there. So when we're talking about populated areas, so which kind of accidents can happen because of drone? So final investigation report on, like, it's not just drone, any other aviation failure if is there, it's if airline is there, drones are there, or any airborne if helicopters are there or something else, then everything they will report it over here with the detailed descriptions. So you might be knowing about this Ahmedabad plane crash and different kinds of accidents which happened. So you can collect the data for all from this particular site, that where it happened, what might be the reason, and you can generate the entire database also from this. So these are the like different things are there. So you can explore this site if you're interested in drones. Uh, so here it should have some kind of zones. So this pariksha is like examinations for crew. So yeah, I mean you can explore these things. So you might get some zones maps. I'm not able to find it right now, but you will if you explore this, you will get this like let's just search it out. Drone zone. So yeah, so there is a this is DG Sky, Digital Sky thing is there. That is also from DGC only. So there you can check out like whether you can fly drones or not, in which area, which you need to take permission. So just wait to open this site. So this is the map of India. So here I'm in if I will talk about my current location, so it's in Gujarat, Gandhinagar. So as I will zoom it, then I will able to see it like which location. So here the airport is there. So you can see this particular zone is not available, and then and the different buffers are there. So in that zones I cannot go. Then particularly I'm living in the Gandhinagar in IIT Gandhinagar. So here also you can see various secretariat buildings are there or offices, government offices of there in the Gandhinagar because of capitals, courts are there. Here one kind of military base is also there. So because of that also you can see this is the restricted area. So if I want to do something drone flying at some height, then I have to take permission because it's falling in the no flying zones. Then so this red ones are the air airspace map is dynamic in nature. Please check the zone restriction before the every drone flight if you are doing. And then after you can see like which airports are red. Airports like within 5 to 8 kilometers from airport, it's a yellow band. Then for 8 to 12, it's a kind of light yellow. Then international boundary, so like 25 kilometers less than that. Then red zones where you cannot fly, and then temporary red zone because of some issues. So these are the boundaries also you can see the 25-kilometer buffer. And then in Delhi also, I mean, if you see in Delhi, there's lots of areas which are restricted because of one or another reason. So yeah, the if you are doing a drone survey, you should look into this and then only you should plan your drone survey. Otherwise, it might be create problems while surveying. What I was telling about the topographic survey. So if you consider this size of uh, which we want to survey, and then you in one side you are having the land survey and one side you are having UAV. So for less than 10 acres, your land surveys are cheaper. But if your area increases more than 10 acre, then the drones becomes very easy. And then after some time, like you cannot cover entire area in just one day. You have to take breaks and you have to do multiple times. So it will include a more number of people also. So the cost will increase by some after some particular acres, and then you will again have same similar kind of cost or almost. And then again after some kind of if area requirement like smaller, medium, and larger area. So according to that, it will decide the amount which need to be invested for survey. But if you see if your area size is more than 40 acres, the you can see a lot of distinction between the cost of land survey and the UAV driven surveys, and because of that you can save this amount of money. So yeah, next thing is, now this is all about drones in general. Now we will move towards the classification of drones topic, the slides. So drone can be classified depends on the various kinds of things. So if I want to classify drones, it can be classified based on their wing, based on their sensor, based on their weight, range, automation, and application. So it can be anything. So can anyone give me the idea, like, or do you know, like, what are the different types of wing type? How it can be classified by wings
The hybrid, fixed,
and rotary? Yes.
and
So
multi-rotor.
yeah, so fixed wing where the wings are fixed. Obviously, rotary is like its propellers are moving. It can be anything like quadcopter or hexacopter or tricopter. So whatever it's there. And then hybrid where you have both fixed wing also and some kind of propellers as well. Then it can be depending on sensors. So what kind of sensors you have in drone? So till now, what kind of sensors you have learned in this course? I mean, can you give some idea on that?
But actually, their name is not
Okay, so here sensor
like
is not just you have to remember the name, but like it's like, see, if you want to measure thermal thing, any related to thermal, then infrared sensors are there. If you want to measure RGBs, then multispectral sensors are there. If you want to measure the different things like micro properties, or if you want to differentiate between two things, then you have hyperspectral sensors. Okay, if you want to measure height and all those things, then you have lidar sensor. So keep things like this. Okay, so these are the different types of sensors, and in that it can be anything like which thermal sensor, so that we don't bother about. But you should know that what are the different types of sensor in terms of it might be infrared sensors, microwave sensors, which we use in active remote sensing, while synthetic aperture radar and all. Then multispectral sensor, which we use in Landsat and Sentinel. Then we have this hyperspectral, which is there in Hyperion satellite. So like that, different sensors are there. Then depending on weight, any idea like how the classification is being done? So obviously there
the
will be
mini,
mini, mini,
the
nano.
mini, micro,
Yes,
nano.
yes, exactly, exactly. So range, then further how can far it can go, then automation, and then application. So these are depending on like fully control mode and all. So now let's we'll see something on that also. Okay. Yeah. So a drone can be classified based on, so which of the following
The
is or
wing
are the
weight
following?
and range.
Wing, weight, and range. Anything else?
Yes.
Option B, sir.
Yes, true. So sensor application and automation is also true here. Here pilot is not the word and color is not the word either. Option number one. Which of the following is not a matrix to classify a drone? Weight, automation, speed, and rotor?
So speed.
Yes, so speed is not the correct metrics because we do not have like proper classification based on speed. But yeah, if you compare in overall like coverage, then we have that like fixed wing can cover a larger area compared to the rotary wings. But yeah, but still that is not a parameter to classify. Now select the odd one out. So this is the classification based on which matrix, first of all?
Wings.
So based on
Yes,
rotors.
true. Yes, so based on wings, true. Now which of the following is incorrect here? So the first initials are representing number of wings drone have. So what do you think? Like, is it 5, 3, 4, or 8? Which it cannot have? Or which one is which you think it's not fitting here?
So tricopter.
Tricopter, okay. Anyone else?
Sir, pentacopter.
Yes, so the correct answer is pentacopter. Tricopter drones are there. So if you see those kinds of drones are there. So tricopter drones are like this, but there is no something like pentacopter. I don't know. Yeah, some drones are there. Okay, so it can not be, yeah, but it might be not that famous. But yeah, in that case, all the options are like nothing is odd one out. But yeah, if you see in general, as per the slides given to you, the correct answer here is pentacopter. Okay, so the next one is which of the following is true about wings of the drone?
The wings are either fixed or rotatory.
Okay, okay, anything else?
And a drone can have both fixed and rotary wings.
Okay, so option C and D both are correct here. Okay, then we'll go to
So
the
C is
yes,
no.
yes,
Yes, sir, both are correct.
yeah. So wings are either fixed or rotary. So it means either it's fixed wing drone or either it's rotary drone. So anything like individual also be possible, and it can have both together, which is a hybrid drone. The next one is which feature is true about the high endurance UAV? So I mean, this is like things you have to keep in mind. So I will just show you the things so that you don't have to recall it right now. So basically, high endurance UAV, which are mostly fixed wing UAVs. Why high endurance? Because obviously, compared to rotary drones, it has more power, more coverage, and more time it can stay in air. So when we compare this, it's like it has more than 90 minutes of flying time. It can cover the more than 8 square kilometer in just one mission. It can have the payload capacity of 4 to 5 kgs. Then 18 meter per second cruising speed it can have. Then 24 megapixels camera is there and plug and play sensor capability, and then we have 12-kilometer communication range. So now considering this, I will just give you a few minutes, just look into it once again. Now based on this, please give me the answer that which feature is true about the high endurance UAV.
So 12 kilometer of communication range
Yes.
and also can carry a weight of up to 3 kilo.
No, no, it can carry up to 4 to 5 kg. So not up to 3
So,
only. It can carry 4 to
but
5.
here it is mentioned like can carry. It is not like what is the
Yes,
maximum
yes,
capability of it.
yes, yes. But can carry weight up to 3 kgs only. So it can carry more than
Oh,
that
oh,
also. So that is like limiting statement. Okay, so yeah, it can be framed better way. So it can carry just a weight of, or at max it can carry a weight of 3 kg. So yeah, it's a typo. Yeah, it's depending on the language things you can check out. But keep in mind those things. Which of the following is true? The flying height of a fixed-wing drone is less than that of multi-rotor drone. The coverage of a fixed-wing drone is more than the multi-rotor drone. Flying time is high for multi-rotor drone, and the range of fixed-wing drone is more than that of multi-rotor drone. So flying height for fixed-wing will be less only or high.
they're confused in B or T.
B or D.
This coverage of fixed wing drone is more than that of a multi-rotor drone, and the range of fixed wing drone is more than that of a multi-rotor drone.
Range means what? How far it can go.
Yes,
Okay,
sir.
so what you can see here. Uh, so now this is the classification, like differentiation between this multi-rotor and fixed wing. So first of all, see, flying height is up to 500 for multi-rotor. Then fixed wing, it's till 1 kilometer it can go. Flying time is 20 to 30. Here flying time is 50 to 60. Coverage is zero point 0.4 to zero point 0.8 square kilometer per flight. Here coverage is 10 to 40 per kilometer square per flight. Then range is 5 kilometer and here range is 30 to 60 kilometer. So fixed wing has more height, high flying time, high coverage and high range. Okay. And apart from
Yes, in
that,
this way,
what is the advantage of multi-rotor is it's a cheap, easy to operate, whereas if you are going with fixed wing, it's expensive. You need a like operator which can operate this, because as you go up, winds will also like increase. So you need a very good and good aero resisting aerodynamic system which can like be proper stable in that kind of situation at that altitude. And another thing is when we talk about landing, so drone generally it will just go like it will just standing, then it will go up and down like this. So the landing in case of multi-rotor drone is up or down. So it's a vertical and easy landing. Whereas in case of horizontal, it's like plane only. So it's going like this and then coming down. So the landing will be horizontal landing, and we need a sufficient space like we need for aeroplanes. Then flights are short and coverage is low, so that we already seen. And then suitable for local mapping multi-rotor, whereas this fixed wing is for larger area. And this compiles within the aviation regulation, but another one we need to have this permissions. So if you have seen this survey of India has launched, there is some of the. So first of all, we'll just see the answers. So what will be the answer now?
so B and D both.
Yes. So answer is B and D both. So what I was telling is that Survey of India has launched some of its problem or program. Survey of India survey. So this is the scheme or the program that they have, Samvita. Have you heard of it?
Yes, sir, Swamita.
So have you heard of heard the name of this one, this initiative? of Survey of India?
Sir,
So
only
this,
name,
yeah,
not
so
about
this
its
is
detail.
from Ministry of Panchayat Raj, and why they are doing is they want to map the all the properties. So if property is there, then they want to
Yes, sir.
take that. Yes. So I mean,
Is
I
it
don't know.
about that red line, like property under red line should be mapped also now?
I don't think so that, but what they are doing is they are creating digital records of every property or every land parcel. So they are collecting data using drones, specifically this fixed wing drones, not the rotary drones. And then after they are digitizing that land records, and then after they are assigning that person who is the owner of that particular land to avoid the different kinds of issues which has, while like if some project is going to happen, then what will happen that all of the sudden someone will buy that property and something like it's not from that side or that registered on that person's side. So to avoid those issues, Ministry of this Panchayat Raj has started this initiative basically to assign the owner names or owner information with this drone survey imageries. So I mean, if you go here, they are using this drone survey, like drones like this, and 281,589 maps are already handed over to different states. And if you will click on that, you can see like how much drone survey has been completed. So around 3,17,329 villages drone surveys are already done, and then they are preparing this card. So I don't know, some in Uttarakhand and all they already started, in lots of villages also they have started. I mean, if you go to this site where they have this dashboard, there you can check it out that at which particular location or at which particular state and district how much survey has already been done, how much parcels have already been digitized. So I don't know, my internet is leaking today, not to open the sites. So let's so this is the like with different districts or state they are doing this kind of MOUs for this. So basically, what are the deliverables? Like what will they will do after doing this thing? So they are going to provide the accurate georeference digital maps based on the National Spatial Reference Framework of the country. Then they will generate the village level map LPM on 1 to 500 scale, and the accuracy of it will be plus or minus 10 centimeter in plain areas, and DEM the height accuracy will be plus or minus 20 centimeter in the village abadi areas or in plain terrains. Then you will receive the hard copy of maps at 100 to 500 scale. Then four numbers of each for final village map for good quality 90 GCM paper along with a PDF copy for future printing purpose. And then training course and for technical staff and administration of whatever the state is there, to train them for this kind of further assessment and further if they want to carry it out. So I mean, yeah, you can know more about this particular program and then scheme basically, and you can just check it out that how much it has done in each of the state, how many things is completed. So see, if we see the Gujarat here, and they have this GIS dashboard. So if you go there, it will also open the same dashboard, similar kind of how much it has done. And then it's also dynamic also, like it will also show that right now survey is happening in which particular village. So it has this all the marks which are going on. So if I am able to open this portal, then you will see that thing. So yeah, this is taking time. I don't know why. So So drone surveys, then this is the maps handover, land parcel digitized. So you can look into any of the things in detail, like at district level and tehsil level, what are the things which are happening. And then they are having their presentations. So there you will get to know more about their particular things. So yeah, it's got downloaded. So you will get this kind of Excel files where you will get to know that in which area of Gujarat. So completed date when that survey got completed. So you can get the name of the district, sub-districts or village, and then after the survey date when it got complete. So you will get a detail like this and you can see in detail those things. And then, so this is the current day, like 9/12, yesterday's map. So you can see how much work has been already done. So if we see the today's data, so drone on off you also you can do. So currently they are not flying any drones, so because of I think monsoon season or something. So basically we'll just take some. So you can see the drones are there. So during 3rd of August 2024, they have carried out the 2 surveys in the Haryana, then 5 surveys here in, then around 1 survey in Gujarat, then 22 surveys in Rajasthan. So you can get all those details. I mean, so that's it for this portal. I mean, if you are interested, you can look it more. And this is their presentations, good practice, what they have observed, dashboard design, how they
So
have.
can we
Yes,
so can we access that digital maps?
yes, it's able for everyone. So this data map is everything. Like you have to open this site and you have to go to this GIS dashboard. So you will getting these things.
And are these 2D map or 3D maps?
It's 2D map. So there are 2D maps
So
only.
is it similar like digital twin technology?
Digital terrain or what?
So digital twin, which is
No,
like
no, no, no.
replica of
Digital
any
twin is
particular.
something else. Digital twin is also something else. Like digital twin, you need exact replica of what you are having. So if I'm having
Yes.
campus, so it is the same replica of the campus, and then we will like it's kind of beam modeling or building information modeling. So it's similar to that, but it is just a 2D visualization of they are doing. So it's a dashboard is very static. They just have a layer of uh, just India's districts or state. Here they are keeping state, and in each state at corresponding date, what is the value? That here what we are seeing is that what is the status and how much it's done. So in UP 911, like around 91,195 surveys are done. So just static layer, and these drones are showing at corresponding date how many surveys are done. So out of this in Rajasthan, let's say 35,778 surveys. So on this particular date, 22 surveys were carried out. So it's just very simple dashboard, and this is like full form of this is survey of villages and mapping with improvised technology in village areas. So here, I mean, so I mean here I will just show you these are the CORS. So CORS like we discussed during GPS, it is useful for keeping the like the corrections to if we are using GPS in our drones or something, then GPS, DGPS or drones, then it will help us to correct the corrections because which are coming into atmosphere or some the common error. Then this is like what they have done. So it's like same what we are learning in this course. So how they implemented same thing, drone survey, planning survey, then extraction, then inquiry process and all. Just see if some kind of images of drones are there. We can check it out. Okay, here is not there any drone image.
So, like if I'm not wrong, so we use cores for corrections.
Yes, so for like we use not as georeferencing, we need georeferencing. So to avoid the
Yes, sir.
georeferencing, what they did, they fitted the GPS chip inside the drone, and then they collected the data. So GPS accuracy is not there. So like every time it's not that good. So they are using the DGPS principle, where you already know the location of one point and you will correct the location of another point using the given standard errors. So that's why they use this
Means
course.
coursework just like as in reference point.
Yes, yes. So course acts as a GCPs. So this is like how they are doing it. So you can see here how exactly they are going to do with this. So I think, see, this is a fixed wing drone with some rotor. So it's kind of both hybrid. So you can see the propeller also and the fixed wing also. Okay, so this is the kind of thing how they are doing this surveys. So you are, if you are interested in this kind of stuff, you can join these organizations also afterward. Yeah, yeah. So we go back to our class. Um, yeah. So which of the following pair is false? So multi-rotor, horizontal landing, fixed wing, horizontal landing, multi-rotor, vertical landing, and fixed wing, vertical landing.
The fixed wing horizontal landing and multi-rotor vertical landing.
Yes. So option number A and option number A, multi-rotor. Sorry, option C, multi-rotor vertical landing, and then fixed wing horizontal landing. But here I have asked which of the following is false. Okay, so answer will be opposite to. Okay, did you get my point?
Yes, sir. Got it, sir.
Yeah, so here the answer will be A and D because those are false. B and C are correct. What is the weight of the nano drones? So I think I will first see because these are like things which you have to keep in mind at some point of extent for this course. So rather than asking you questions, I will just show you and then based on that you can recall it further. So depending on weight, we can classify drones as nano drones where the weight is less than 250 grams. Micro drones, the weight is between 250 gram to 2 kg. Small drones 2 to 25 kg. Medium drone 25 to 150 kg and large drone greater than 150 kg, and these are the classification provided by DGCA. Then classification as per weight and range. So that is another table. So you can see nano, micro, mini, light, small, tactical, small, heavy and super heavy. So keep in mind this some words, tactical, male, hell, because those are not in general. This nano, micro, small, medium, large is there, then you can arrange it properly as compared to their weight categories or range categories or categories, other categories. So now as the weight is increasing, what is happening? Range is also increasing. So you can see if we are going from nano to super heavy, range is also increasing and weight is also increasing. And you see that if the weight of drone is less than up to 50 kgs, then it can have multi-rotor, but as the weight is increasing, then after it becomes fixed wing drone or hybrid. So based on that, what is the weight of nano drones?
So less than 200 grams.
Yes. So now the next question is which of the following is true or are true in terms of drones?
The high weight means the high range and less weight means less range.
Option number A and option number C. Now select the correct options based on the drone weight.
Nano, micro, small, medium, large.
So option number
Option
B.
B. Option
B
B.
or C? Option number?
Sir, yes, sir. Yes, sir. Actually, I have to see that sign. Sir, option B. Large.
Yes.
Yes, sir. Nano, micro, small, medium.
The next one is select the correct option based on the drone range.
It's the same option B. Nano, micro, small, medium, large.
And which of the following is the active sensing sense system in drone? So altimeter, sounder, radiometer,
It's a
and spectrum.
spectrometer or radiometer.
So I will show you.
Sir, radiometer, and because
Yes. So
spectrometer is,
radiometer, like
I
we
think,
will. Yes.
yes, a spectrometer is an individual instrument or tool we can see.
Yes. So spectro, radio, sounder, all are passive. Altimeter is only one, which is the active one. So if you see here, so here we have active sensor and passive sensor. In active, we have altimeter, which is useful for measuring heights. Preferably, we use it the water surface elevations using this. So there are various altimeter satellites are there, which we use. Saral Altica is from the India, so that is useful for water surface detection. Then lidars are also active remote sensing that we already learned in the previous class. Then radar is also active sensor. Then ranging instruments, like ranging means the light will go and then it will come back, we will measure it, and based on that we will calculate the distance. Then there is a scatometer and sounders. So here in this case, sounder and altimeter both will come as a active sensor. Then we have passive system. So there it's accelerometer, hyperspectral radiometer, imaging radiometer, radiometer, sounder. So sounder comes under both, like depending on how we are using it. Like, do we have any source of energy source in sounder or not? Depending on that, it will act as an active and passive. So if just name sounder is given, it can be anything. But if specific things are given, that which sounder, or then we can decide whether it's active or passive. Then spectrometer and spectroradiometer, that are like just whatever is falling on sun, we are reflecting it back through the object and that we are recording. So mostly it's a passive systems which uses the energy of sun. Now the next one is, which of the following is not a part of mission planning?
So ground sample distance.
So that is a plan. Why? Because when we decide the survey, we have to see that which specific spatial resolution we want to do survey. How much area it will cover from 1 pixel to other, or 1 pixel. In 1 pixel, how much area it will cover. Flight goals, area of interest. So here, like compared to all the four options, the least important thing which we do not have to worry about mission planning stage, that will be ground control point. And specifically, if we are using GPS, then there is no need of using ground GCPs. Okay, so comparatively, compared to all the four options, GCP is not part of mission planning. And if you see this principle working for photo UV, so this is mission planning. Generally, we use flight parameters such as ground sample distance, area of interest, camera information, flight goals, and UAV platform which we are using, autopilot mode or ground control stations. Okay, not the GCPs. So ground control point will come as an additional parameter when we are doing the image triangulation or digital photogrammetry. So it will play important part during that time. Okay. So feature extraction, ortho image, 3D modeling, DSM, DTM generation, all those things will come during digital photogrammetry. So which of the following is a part of digital photogrammetry?
Feature extraction.
Yes. Now in one flying, a high endurance fixed wing UAVs can flight time more than, so we saw that fixed wing high endurance UAVs. So how much it can fly? So it's 90 minutes, more than 90 minutes. Next is identify the correct pair of drone types with their maximum ranges. So again, this is the question which you have to remember. So I don't know. I mean, all four are here. So we'll not focus our time on this. Which of the following is a thermal sensor used in drones? So now out of this given four, which of the following is a thermal sensor? So here the FLIR Duo is a thermal sensor. I mean, if you have heard, I mean, this is the very good example because during COVID, there's like FLIR companies there, they are giving the thermal camera only. So this very popular company for infrared sensors. So many people have used during this COVID time also this kind of guns, thermal guns. So this is the one of the biggest company or which is providing this thermal sensor and it will look like this. So these are the different scanners for house. So basically it gives these thermal infrared cameras. Which of the following is not a quadcopter components? So I think now we'll go and first check out the components of drone and then we'll go to the further questions. So if we take quadcopter, then it has different components such as props or propellers, motors, then we have electronic speed controller, then we have flight controller, then E we have airframe, I we have front indicator, J first person video camera, K receiver. So we have this kind of external component. Propellers are like it uses for generating like the directions and rotation. So what how it's going to work like all because of the propeller. And then it uses the two puller and two pusher props. So once you if you see any drone, then you will see there is a color variation on the diagonal uh, propellers. So based on that, you can identify which one is which going to fix at where. And here there will be a small indication also that you fix black one here and gray one here or white one here, such kind of thing. Then there is a motor. So quadcopter uses motor to turn on the propellers. The motors can be brushed or brushless. So brushed ones are cheaper and having cheaper quality, whereas brushless are typically higher quality and more complicated. Then we have electronic speed controller, which is needed to control the brushless motor. If you are having brushless, then it will be useful. Then we have flight controller or autopilot, so which will assist in manual flight along with the some autonomous functions. Autonomous functions like go up or start and go up, then return back to location. So these are some kind of autonomous functions. Then airframe. So airframe is a consist of housing, enclosing the electronics, motor room, or platform, and it is also known as a chassis. Then there is a battery pack which powers the quadcopter electronics and keeps the propeller running. And then it's also as a Leo polymer battery. Then we have the other parameters which are like camera gimbal, so it will serve for recording purpose, and gimbal is like it will keep the camera stable while the flight is happening. Landing strut, it will helpful to land the drone on the ground. Front indicator, it operators uses the different methods to indicate the front. So if you see drones, there will be two kinds of light, green light and red light. So green light, it's on front end side, and red light on the back end side. So using that, you will get to know that if you will give pitch forward command, so whether the drone will go in which direction, which is the forward direction as per the drone, it's not as per the us. So these colors will help us to determine if we are giving a given control, whether it's a pitch forward or pitch backward or move right or move left. So how it will go. So depending on these colors, it will decide. Then the first person video camera. So that video camera that allows the image to be transmitted to the user. And then there is a receiver which translates the user's instruction for. So receiver, what it will do, it will translate the whatever instruction which we are giving to flight controller. So these are the external parts which you can see through your naked eyes. But if you see internally inside the drone, then there is a microcontroller. The microcontroller is the brain of a flight controller. Then it collects and measures the from all its sensors, tells motor how what to do based on what both the sensors and users input. So basically it's the connection part it's doing. Then you are having IMU, so inertial measurement unit, which will keep the drone stable and for necessary for autonomous flights. So it like when you are doing this inertia or movement led thing, it incorporates accelerometer, gyroscopes, and compass. Then you have GPS, which will give you the idea about the location and the time information. Then you have altitude and heading reference system, AHRS, which will give you the information where the aircraft is moving and what is its orientation. So whether it's going right direction, front direction, and at which angle. So all those information will be getting by we are getting from AHRS, whereas its stability is determined by IMU. And then we are having transmitter. So transmitter will transmit the instruction to the receiver via radio waves. So these are the inner core parts, and then we also looked at the external parts of the drone as well. So which of the following is not a quadcopter component? So electronic speed
The
controller.
side indicator.
Yes. So instead of it, it should be a front indicator. Which statement? Chalo, we'll come back to that questions afterward. I think chalo, we'll take it only. Which statement is or are incorrect about the rotation of drones? So basically, when you take drone, it has like movements like this. So if any movement is happening, rotation is happening around the y-axis, then it's known as a roll. So if you do the rotation around y-axis, you can go either right or either left. So if your drone is like here, then either if you do like this rotation, then you can go towards the right side or left side. Then if you pitch is a direction around x-axis like this and like this. So using that you can go either forward or backward. So when we give the drone instruction, so how it will do that you are having control in the both hand. Then it will be like pitch forward, pitch backward, roll right, roll left. Then there is a another thing that you want to take a turn. So it will be around the z axis. Then that is known as a yaw. So that is known as a rotation about the z axis. So yaw right, yaw left. So if you go for any drone training institute, they will give you the instruction like this, that you are having drone controller in your hand, and they will give you like pitch forward. They will not tell you that move forward, move backward, move right, move left, move right. So instead of that, this will be pitch forward, pitch backward, row left, your left. And then how these movements are named. So if we see in terms of aerodynamics, then if we are going up, then it's known as a lift, and then landing, it's weight. Then if we are going in this direction, then it's known as a drag force. And then if we are rotating in this direction of x pitch, that is known as a thrust. So this like keep these terminologies in mind while preparing for any exams if you're going out, or any just for drone licensing also. If you go, just keep those things in mind. Now which statement is or are incorrect about the rotation of drone?
The roll rotation about the x-axis. See,
Everything else is right.
no, sir. Pitch rotation about the y-axis.
That is also wrong. Now pitch is about x-axis, roll is about y-axis, so that is also true, because false, I mean.
Yes,
Okay,
u
so
is about the z-axis, not
yes.
roll.
So the next one is about the UAV operation. The correct statement is or are: pilot in command is ultimately responsible for the safety of UAV during flight. The UAV for civilian application can fly at 1 kilometer above the mean sea level. If the battery is consumed, UAV will crush in air. And visual observer to watch the sky for intruding aircraft and watch the unmanaged aircraft. So here option number C is correct. The next one is which of the following is not a step in mapping procedure using the UAVs? So which of the following is not a step in mapping procedure using the UAVs?
So recognizing.
So reconnaissance is a survey which we carry out at the initial stage using maps or satellite images. So that is a part of mapping. But if you see project design, it's a it's also part. Then quality control, it's also part, because whatever data we are collecting, it should be a quality data. But data post processing, that will happen once we collect all the data and we will handle it. So this processing part is not a like thing which we do during mapping procedure. It can be done afterward. Which of the following is or are applications of drone? Air quality monitoring, tunnel survey, oil spill survey, and monitoring transmission lines. So this one is very easy. What should be the answer? Is it easy or tough? Or you guys are not able to decide? Okay, so air quality monitoring
So,
we can do. Yeah. Yes.
so like some questions are easy, but language is not easy. Like we have to focus on the language, but
Yes.
they are trying to ask us.
So this NPTEL exams will be like this only.
Yes, sir.
So you
So
should
in this
focus
air
on.
quality monitoring is not the application.
No, air quality monitoring is the application. So there will be air sampling sensors are there, which are specifically
Sorry,
monitored.
sir. it's my bad. Monitoring transmission line is not application.
No, that is also a thing like we used in lidar also, that if we put lidar sensor on drone, we can monitor transmission lines, we can find out where it is having issues. So monitoring transmission lines is just flying a drone around the transmission line, that's it, nothing else. Tunnel survey, it's inside the ground, so we cannot do. But oil spill survey, it's like on the surface of ocean only. That oil got spilled, so density of oil is less, so it will be on top only, it will not go into the bottom. So because of that, oil spill survey is also an application of drone. Okay.
Sir, but I have doubt about this monitoring transmission line. Like transmission line, is it not about underground lines? Like
No, 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 no,
we
no.
have some.
No, 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 no. Transmission line is like power cables and all those we have like in like roads.
Okay.
So it's like that.
And so what about this air quality monitoring?
That
Like
we can do.
how they do this?
There are particular sensors are there which are air quality specific for that only. So there are air sampling sensors are there. So this is like for transmission line. This is how it will be helpful. So there is in PPT, if you see, there is a particularly mentioned on one slide. There are sensors named as a air sampling sensor. So they use that samples and then they find out the microorganisms which are present in air. Okay, so which of the following is not a component of fixed wing drone?
So sorry to
Yes.
distract you, but I had doubt in previous question.
Huh?
Sir, tunnel survey, like can't we do tunnel survey using UAV?
Tunnel, see, first thing is if we go for tunnel, then it's an inside area. So first of all, we will like do not have access to GPS. First thing. Second thing, there is no particular light, so it will not capture anything. Third thing, will not have because of that GCPs. So mostly drones are not useful for underground things. Like it can be useful at some extent. Okay, like if you want to, like it's not that key, you cannot do any survey like tunnel survey without drone. But yeah, if you see there is an issue with GPS and like how we control, because in tunnel it will lose the signal most of the time. So let's see, can we do it or not?
Means sometimes we have to decide by comparing the options.
See, so here they are using it. So see, so it's not that every time, like for this also, if you fix something GPR sensor on drone, then you can do the subsurface survey also. So sometimes it's like you have to think what is not, like if you think it's all for, then you just go for it. See, it's drone is something like if you fit the sensor which is relevant to that application, you can do that thing. Okay. So here tunnel survey, here also like we can do, see we can do it. We will keep it. There is no issue. But it all depends on the one who set the paper. So
So the
uh,
same thing happen in the assignments, and
mm,
I in
mm,
every assignment I
yeah,
got only 80 to 90 score. I got 100 score only in one assignment till now.
yes. So, I mean, this all goes to the one who is setting the questions, and these are like mostly theoretical questions which you have to remember, so that do not make any sense. So, yeah, it's just like for certification, it is fine, but if you are interested, think about the concepts, what like then what kind of applications we do and how we do, and what are the different stuffs are happening in India specifically. Let's say today we see this Samvita, the thing is there. Then if you see drones, then there are a couple of startups which are coming from different IITs where they are using the drone swarms. For that, startups are very big and they are doing a lot of drone shows nowadays using these projections and lights and all. So good thing to know, like this is just a bookish thing. So I mean, just to prepare you for that, I'm solving these questions, but you should focus on the application part more, concepts more. Then here, like concepts, like in few slides, there is nothing useless. Once you will go to field, you will get to know. But yeah, if you want to see what kind of drones are there, what kind of weight they have, what kind of wings they have. So basically, how to check that? You just go to DJI site or any site which are showing you the drones. So then after go to that particular site and see what do they have, like how they have categorized the different drones based on their size or rotors or fixed wing. So it's not about this course. If you are doing any course, try to look into it like how you can collect the different things from various perspectives. So now see, these are the DJ different series, maybe drones. It's like mostly banned in India, not that much now it's available. But yeah, you can check about the what kind of sensors they have, how much weight they have, what are the gimbal specification, camera specification, obstacle detection is there or not, what is the flight time. So here you can see this for drone only, this is offering 45-minute time. And then if you see this kind of drones, they may have some good thing about the other normal drones. So basically, what I suggest is just forget about the questions. If you think uh, in this NPTEL stuff, if you think there is you have written well, and in book if the answer is same that you have given, then you can write in this our chat in classroom. You see one chat box is there, or question answer or discussion forum is there. So if you have given the same answer which is there in PPT, then you can write it there. They will reevaluate your question in that case. But yeah, if you forget something, it's fine. There is no need to worry about it. Okay, so yeah, let's move forward. Which of the following is not a component of fixed wing drone? So here the gimbal is not there in fixed wing drone. Then the next one is which of the following is not a part of quadcopter?
The processor,
Yes. Which component is considered as the brain of the flight controller, collecting the measurement from sensors and telling the motors what to do?
the microcontroller.
Yes. The correct answer here is a microcontroller. The next is what is the key function of a LiDAR sensor?
So to provide three-dimensional information.
Yes, so that data is known as a point cloud data. And to measure the temperature with high resolution, so that is infrared sensors is useful. To analyze crop condition, we have hyperspectral sensors. And then to provide the first person's video, so that is just normal camera. What is
So
the
for
primary?
thermal applications,
Yes,
which sensor we will use? They are not thermal sensors.
which one?
So like for thermal applications, we are
Yes,
using
infrared sensors.
microwave sensors.
Micro and infrared both we are using.
Okay, but are not there any thermal sensors?
So this infrared is like, see, thermal sensor, how they will work is, which principle are thermal sensors are designed. So first of all, what we are considering when we are, like first of all, what we are measuring using thermal sensors.
So that heat emission from any feature or any body.
No, but see, you when you have these questions, which sensors can be useful, think about what we are measuring first. So that is thermal units we are measuring. That what that object is emitting by itself. So you know the black body. So black body will receive some radiations, it will store it, and then it will emit that radiation back. So thermal sensors will get those radiations. Now these radiations are falling in the range of 3 to 10 micrometer. which is in the range of infrared. Okay, so how you can measure? You can use Wien's displacement law, which is lambda max is equal to 2898 by T, where T is in Kelvin, lambda is in micrometer. So once you put this formula, let's say if you have any object which is at, let's say, 600 Kelvin, so you will get around 3000 by 600. So you will get around zero point 0.5, sorry, if you have, let's say, some object is 1000 Kelvin, then you will get around 10 micrometer. And if it is 500, then you will get around zero point 0.3, like that. So based on the Wien's displacement law, you will get what is the maximum wavelength it can emit during its emission. And that is falling within this infrared and microwave region. Along with that, you have to see where the atmospheric window is available to get the energy. If it is getting back from emission also, whether it will be absorbed by the atmospheric gases or it will reach to the satellite or drones. So that we also have to think. So depending on that, you will get to know which wavelength region is responsible for which sensor. So think in this direction every time. Okay.
Yes, sir.
Okay. So now we'll go to the next one. What is the primary purpose of inertial measuring unit, IMU?
To provide the drone's position and orientation for autonomous flights.
Hmm. So is that okay? Now the next one is, so first one, stabilize the camera during flight, that is gimbal, to provide location and time information, that is GPS, and to power the motor, it's a battery. Then what is a orthophoto, as shown in the section of outputs from UAVs. So orthophoto we discussed
Sir, D,
just
Sir, D corrected to the true scale and like geometric corrected.
yes, yes, true. The next one is, in the context of quadcopter anatomy, what is the role of propeller?
So to generate lift by spinning.
Yes. So it's not to regulate speed, okay? It's to generate the lift. So everything, the drone working will be because of these propellers only. They will generate the pressures and thrust and drag while moving, like one is slow and one is fast. So they will generate the difference in the pressure and then it will lift. What is the primary function of receiver in a drone system?
So to
Sir,
transmit
option
radio waves to
C.
the remote.
Yes. So here the role of receiver is to transmit the pilot instruction for the flight controller, not the to transmit the radio waves to the remote control. No, it's to flight controller, not the remote controller. And it is transmitting radio waves only, but not to the remote controller. It's to the flight controller. But if you see in terms of like this statement is more correct here. But anyway, C is also correct. I mean, because this pilot's instructions, whatever it will be in radio waves only, and that are going to remote controllers. So yeah, we can in a way tell. But see here, what is happening to translate the pilot instruction. So as pilot, I'm flying the drone, and that is going to the flight controller, which is established inside the drone. Whereas in this one, to transmit the radio waves to the remote controller. So that is wrong because radio waves which are generating through, like, drone cannot communicate, we are communicating with drone, so it's a one-way communication. Okay, so because of that the C option is not correct. So if I write here the
Sorry,
transmitter, if I write here that to transmit radio waves to the flight controller, then it's fine, it's correct statement. But in this case it's not correct. Yeah, go ahead.
sir, can you explain this? Like to translate the pilot instructions for the
So
flight
if
controller.
I'm saying to drone that pitch forward, मतलब move forward. Okay, so I am giving this instruction through my controller, and that should reach to the flight controller. Now, what is flight controller? So as we have seen in PPT, that this is your flight controller like this, which is mounted inside the drone. So it's over here, see. Okay, and then there will be another controller, which like you have, that's kind of remote control joystick that you have. So you are telling through that joystick that move forward. So it will transmit the radio signals, and that radio signal will reach to the flight control. Are you getting my point?
Yes, sir.
Yes, sir.
Yeah.
So then, like, what is the answer of then option C?
Option C is
What
wrong. Why?
transmit?
Why?
Yes, sir. Option A
Because
is wrong. Yeah.
yeah,
But
why
what
it is wrong?
transmit radio waves to the remote controller?
So we are not transmitting to remote controller. We are transmitting it to flight controller. Remote control is with you, so drone cannot communicate with you. Okay, you are telling, like you are instructing the drone that move forward, move backward. Drone is not doing any kind of uh, communications with you. Like we learned in the GPS also, that when we are user, we can just receive the signal only. We cannot communicate with the satellite. But if you are in control modules or control station, then you can receive the data also, and you can control the satellite also. So that is two-way communication. So in drone, this one-way communication is only happening. Any doubt in this still?
No, sir. Got it, sir. Thank you.
What type of sensor is used to analyze crop conditions?
Sir, multispectral camera.
So see, now you have to think critically here. So what is given, that crop condition? Okay, now if crop condition is good or bad, or if it is deteriorating, how you will check it? That color of leaf is getting pale. So if too good vegetation is there, it's bright green or dark green, and as it starts uh, like getting weak, the color intensity of green will reduce, it will become yellow, and then something reddish type. So color variance is not that much if it is going from one stage to another stage. So if you will just use multispectral cameras, you will not able to get it, because it will have almost same in the infrared region, the spectral signature will be same. So that you need multiple wavelength, which can be done using hyperspectral. Okay, but here the option is hyperspectral is not there. Okay, so the probable option with which we can go is multispectral. Why multispectral? Because in RGB we cannot determine, because whatever will happen in like crop, it will be reflected in near infrared band, not in RGB band. So that is not correct. Thermal also, it will not give the thermal signature. All this because of the chlorophyll content. Multispectral, yeah, because we are getting the reflectance in infrared. But here, if the option is hyperspectral, we should go for hyperspectral. But if the option is not hyperspectral, then we are going for multispectral, just because of the near infrared band. And lidar sensor is for, like, we are getting the three-dimensional information, not the anything related to the condition. Okay.
Yes, sir.
Okay, yeah, the next one is what is the primary reason for low endurance for many micro drones? So why micro drones are not able to, like, not high endurance? So endurance means like
So
how
they
much time.
limited onboard power.
Yes, so power is very less as their weight is less. So because of that, endurance is not that. The next one is, which of the following is not an output from UAVs?
Sir, soil reports.
Yes. Then how does a quadcopter achieve forward motion?
So the rear motors spin faster than the front motors.
True. So rear will move faster. Because of that, it will create a difference in pressure, and because of that, it will go forward. Now, which sensor would be most suitable for a mission to detect microorganism in the air at specific altitude? So there are air sampling sensors which is useful for this purpose. Which of the following is an output from UAVs that specifically represents the elevation of bare earth, excluding buildings and vegetation?
So
So DTM.
DTM
Yes, true.
is the test.
In the context of inner electronics, what is the key difference between an IMU, which is inertial measurement unit, and a altitude and heading reference system, AHRS?
So option A as provides a more refined output, specific
Yes,
information.
so option A is right. So this kind of questions you might expect in exams. What is the primary reason that computational intensive tasks such as target detection and search and rescue are normally performed by offline processing modules in remote location? Basically, here what we are talking about is some flood came, some landslide came, some earthquake came. Then in that case, we are flying drone by ourselves, not in the autonomous mode. So why so?
So because they require more power and computing resources than what is available on board the UAV.
Yes, true. The next one is which drone component is also known as a chassis?
The airframe.
That's true. So with this, we are concluding today's MCQ on drones. Hope you like the framing. Something is there like framing. We have to focus more on words. You have to also see whether it's true or false, not is written or not within the question or not. So keep those things in mind while writing the answers, and also go through this kind of questions before your exams. This will be helpful for you. Uh, that's it. So yeah, any other questions, suggestions on this sessions, how we are conducting, anything
Uh,
that needs to be
I
improved? Yeah, go ahead.
sorry for like this may be an illogical question, unlogical question.
Yeah, yeah, go ahead.
Uh,
No question
so
is.
like sir, in the concept of drones, there is
Yes,
a major problem which is about the power, like timing.
yes.
Like we have limited time because of the battery. So can't we increase the number of batteries to increase the time period for the survey?
Yeah, so generally, if you will increase the battery, like one thing is you can increase the number of batteries, or else the second thing is you can increase the size of the battery, like how much storage it can have. But ultimately, what will happen? It will increase the payload. So, if it will increase the payload, then it cannot lift up. So, basically, you will do all the calculation. If this much weight has to go up, then how much uh, weight it should have. So, after that, you have your entire drone infrastructure, and then you see how much space or weight you can keep it for battery. If you have more weight, then you can put a larger battery, lithium ion, or which can store more power. So basically, when you are going from drone to satellite, that is the case which is changing. Then when you are going for satellite, you are putting it out in a space. So the battery which you are putting, that is too many. And not only that, it is also getting power from sun using this like solar. It is also getting power from that. So the main issue with the satellite drones is are that only that it's a battery issues. And that's why like in aircraft, if we have, then it is aircraft or helicopter, it will be operated by fuels. So we can do a efficient survey of larger areas. And that is the limitation of drone. So it's all depends on calculation. So if you want to increase it more, uh, so like just do the calculation how much it required. If you want to increase it, how far we can go. And that's it. I mean,
Yes, so thank you for this clarification. So, okay, this is okay, but like after like if a battery is over, like if we have used the power of any battery,
mm,
so can we charge it again or it is not usable?
no, we can charge it. So generally, what battery I use in my drone? So I have DJI Phantom 4 drone. So in that, we that battery will go for around 30 minutes to 35 minutes one time. Then I have to charge it for 6 hours. So there are generally you buy a drone, then two battery will come together. So you put the one battery, plug the one battery, do the survey for 30 minutes, and then it will come back to the original location, change the battery and do the survey again. So like that, number of batteries can be more so that you can cover more area. But yeah, it can in one flight, it can go for 30 minutes at max, this drone. And generally, normal drone, if you will take it, will go for less 30-40 minutes only, not more than that. At max 45 minutes, 50 minutes, not more than that.
Okay, so thank you so much for your clarification.
So, anything else that how we can improve this class or what we can do? So, any suggestion on how we can change? So, I try to incorporate the lecture slides today so that you can go through it and answer the questions. Uh, Apart from that, if you think if we can improve something, just let me know. I will try to incorporate that. And now from next week onwards, we are having numerical things. So digital image processing we are going to start, which have a lot of numericals. So it's a very good to do numericals as always. So we will do solve a lot of numericals. So these topics now onwards are like more interesting, logical, numerical based rather than what we had till now in last 3-4 lectures, which is quietly theoretical. So now whatever thing is there, it's like more practical, whether it's GIS, digital image processing, image classification. So all the remaining weeks content are like morely logical rather than theoretical. So you will expect some kind of logical reasoning kind of discussions in the further classes, which will be also useful for if you are applying for this gate in geomatics engineering. So this is the same topic which we are going to discuss. It's going to repeat be in like same in syllabus as well. So please pay attention in the questions which we are going to solve in the couple of class now onwards in the further week, and also go through the videos as well. Yeah, apart from that, any other questions do you guys have?
No, sir.
No,
Yeah,
sir.
okay. So I just want to ask, like, how do you pronounce your name? I mean, I'm just very bad in pronouncing. I don't know. So it's that Chinese, or how do you pronounce your name?
So it's that shiny.
That Chinese. Okay. And where are you
Yes,
from?
sir.
I just forgot that.
I'm from Tamil Nadu, sir.
Yeah, so yeah, we discussed last time. So how do you find these classes? Is it useful to you?
Yes, sir. It's very useful and informative. You're giving some real-time concept scenarios also. And
Oh,
last class we saw the practical session.
Yes, yes.
Yeah, it's very helpful, sir.
Yeah, so last year I tried, but now I have to, like, NPTEL requirement is like you can discuss what things are there in lecture slides only. So first discuss that. If student ask, then and then we can solve this GIS based training and all. So after a couple of weeks, I'm putting some videos on GIS. So there will be I'm making a video sessions for GIS, particularly all the kind of data analysis, and that will be focusing on India data only. So that video series will come on YouTube. So if you are interested in that, you can subscribe my channel, like where I'm uploading these videos as well, and you will get back to know. If you are interested in that, just do that, and if you have any questions, just get back.
Yes, sir. Sure, sir.
Yeah,
Yes, yes, sir, definitely. Please share the link.
sure, sure. Once
So,
it will be online, I will share it with you. Okay, guys. So thank you for joining today's session. We'll see you tomorrow. Bye bye. Have a nice day ahead.
Thank you, sir.
thank you, sir.